Hi, hello. Welcome to another deep dive into the Windows Subsystem for Linux architecture. My name is Craig Loewen. I'm a program manager working on WSL, and I'm joined today with
Sven Groot, dev working on WSL.
And today we're going to be looking at exactly how the newest update of WSL allows you to access Linux files through Windows. And so luckily Sven is the developer who's made this feature possible, and we're going to jump into that. Before we actually get into how that works, how do we access Windows files again? How does that whole process work?
All right, so let's first take a quick look at how the file system stuff in WSL worked. I've talked about this before, and I've drawn pretty much this exact diagram before, but I'm going to do it again. So if we just make our, let's say, this user node up here. My handwriting is still terrible. That's the kernel node down here. So if you launch WSL.exe, it talks to LXSS manager servers to create a WSL instance, and then that will launch some Linux binaries, like we have the init binary, and that will then launch bash and whatever else you are running. And since these are Pico processes as part of the subsystem, their system calls don't go to normal Windows, they go to our Pico process driver, which is Alex core. So the system calls go there. We have a layer in here that handles the system calls.
And all of these are routed down to the NT kernel.
Eventually, yes.
Right.
A lot of stuff we have to do inside of Alex core because of all the differences between. If it was as easy as just saying, okay, this system call maps to this, this Linux system call maps to this system call in Windows, then it would be a lot less work to do all this stuff. Especially on the file system side, there's a lot of stuff we need to actually emulate inside of Alex core.
Right.
So, for example, if you do an open or stat or something like that, those system calls, they get routed down to the VFS layer inside Alex core. That's the virtual file system that brings all of the file systems together, exactly the same as the VFS layer in real Linux, basically. And that uses different, we call them file system plugins. They're kind of analogous to the file system drivers that Linux would use. We have, traditionally, we have WSL FS, formerly LXFS, which is the internal file system.
And just to be totally clear, WSLFS stands for the Windows Subsystem for Linux file system, right?
Yes.
Okay,
Yeah.
just making sure.
So that's your internal file system. We had LXFS before. This is a slightly updated version of that.
Right.
Did the same thing. This is everything, your Linux system files, your home directory, everything that's inside of WSL. And then we have DriveFS. That is what accesses your Windows files. And then there's stuff like proc and sys and tempfs and whatever that don't necessarily represent physical files on disk. So just finish this box here. Underneath this all is the NT kernel.
Right.
And that has stuff like NTFS, obviously.
Yep.
So both WSLFS, the internal file system, and DriveFS access files that are stored on your real NTFS disks.
Right.
And DriveFS can also talk to like FAT and whatever, but that's not really relevant for this discussion. Even your internal Linux files, they're stored on disk. You can find them. They're like in the store apps directory somewhere.
Right, somewhere in app data. Right.
Yeah. But we've basically always said, like, don't touch that. If you touch that, things are gonna go wrong.
And to be clear, that rule still exists.
Yes,
Please don't go there.
that has not changed. There's a few reasons for that. One of them is that we store metadata in these files, because Linux has like the permissions, the mode bits, some extra file types like FIFOs and sockets and device files and all that stuff that Windows doesn't really have. So we add some metadata to these files that represents these extra things.
Right.
And unfortunately, a lot of text editors, when you save a file, they will strip that out.
Yes.
So that will break those files, obviously. The other reason is that for performance reasons on the internal side, in VFS and in WSLFS, we do some caching.
Right.
So as soon as you start touching these files while the distribution is running, the cache will get out of sync, because we don't look for changes that happen outside of WSS. We assume that we're the only ones that are accessing this stuff.
Right.
So that also doesn't really work. So, of course, people have always told us, like, hey, we want to be able to edit these files. We want to be able to edit our .bash RC file in, maybe not Notepad.
VS Code.
Yeah, whatever. Actually, Notepad now supports Unix line endings.
There we go.
It actually is possible. So people have wanted to do that, and of course, it's been one of the top feature requests for a very long time. So we wanted to find a way to make that possible. And basically, in order to make sure that all of our semantics are preserved, all of our metadata works the way it should, and also other stuff like iNotify events.
Right.
We need to fire, because for DriveFS we use a mechanism to translate Windows file system notifications to Linux iNotify events. But for WSLFS, because again we assume that nobody's making changes on the Windows side, we don't do that, which lets us be more accurate, because there's not a good one-to-one mapping between the Windows and the Linux events.
Right. Exactly.
So in order to make sure that all of those semantics still work correctly, basically that means that when we access these files from Windows, we want to go through this stack.
Got it.
We want to make sure that everything we need to do to make things make sense on the Linux side happens. And essentially the way we ended up doing that is like kind of treating it like a network file system, even though it's like on the same machine.
Okay.
And we're doing that by running should make this button bigger. Running a Plan 9 server inside of init.
Okay. What does a Plan 9 server exactly entail? What does that mean?
So, I've noticed there's been some confusion about this name.
Right.
Plan 9 is like an old operating system, I believe. What we're actually referring to when we say this is a file system protocol that was part of that operating system.
Okay.
That it's called 9p, and the exact version we're using is 9p 2000.l.
Got it.
Which is basically a version of the Plan 9 file system protocol with some Linux-specific extensions.
Okay. So this is a server running a specific protocol, which is the 9p protocol.
Yeah, and we just refer to it as Plan 9 for simplicity, and I'm sorry if that's confusing.
Okay.
The reason we went with this, not like something like SMB or whatever,
right.
There's a few reasons. For SMB, while it would have been nice to use that, since obviously the Windows side already supports SMB fully, whatever.
Right.
The problem is that inside of Linux, well, there's Samba, obviously, and Samba works on WSL, so it sounds great. The problem is Samba may or may not be in your Linux distribution.
Oh, right.
It may not be installed by default. Do we configure it? What if you wanted to or already have a running Samba instance inside WSL that you're using for something?
Yes.
And do we overwrite that configuration? Do we try to coexist with it? Do we have multiple Samba daemons running or something? Like you run into that kind of stuff. And we also, so if you are dealing with a distribution that doesn't have Samba, we can't ship it, unfortunately, because it's GPL, and Microsoft can't really ship GPL code as part of Windows. So there's a number of reasons why that wasn't really a great idea. So
that's how we settled on using the Plan 9 server.
Yeah, and then I mean, we could have written our own Linux SMB server, but SMB is a much more complicated protocol than 9P is.
Okay.
And it just so happened that we already had a Plan 9 server.
Just lying around.
Yes. This was a Windows Plan 9 server. It was actually used for Linux containers on Windows to access Windows files.
Okay, I see.
Because the Linux kernel has a Plan 9 client built in.
Right.
And so we basically ported that server to Linux and use it as our file system server.
Got it.
Inside of WSL.
Very cool. So it exists here inside of...
Yeah, so it just runs in init in user mode. It talks to Alex Core the same as everything else does.
Right. And this is running inside of the distribution
that
you're using. Okay.
Exactly. And it's running in init, so you can't kill it.
Right, okay.
So how does this work from the Windows side?
Oh, so it talks to Alex Core to access this file system.
It just acts like any other Linux program running it. It doesn't have any special privileges or whatever.
Okay.
It does everything completely normal.
Yeah, so when I have a Windows process that's now trying to access some file in here, how does that work, the Windows side?
Yeah, so the Windows side of things, let's make sure I stay in frame.
Yeah.
So on the Windows side of things, you have a normal process like CMD or Explorer or whatever.
Right.
And you're trying to access a path which we've decided will start with WSL $,
Okay.
and then the name of your distribution. Let's say it's Ubuntu for convenience.
Okay.
So when you issue a create for a file with which starts with double backslash, which is a UNC path.
Okay.
Which is normally a network path. You usually put a computer name there.
Yes, exactly.
But what actually happens there is requests of those kinds of file names, they get sent to a driver in Windows that's called MUP, the Multiple UNC Provider.
Okay.
So MUP's job is to figure out who should handle this request.
Right.
And it does that by having a list of what is known as redirectors. There's a couple that come with Windows. The most well-known one, obviously, is SMB.
Okay.
And so then now there's a new one, which is the P9 redirector.
Okay. Is that something we've created, or?
Yes, that's the one we've created for this. And then there's some others, like there's RDP has one. This is if you connect to a machine via remote desktop and you're sharing the host's drives, you can access them via WAC TS client. That works very much the same way as what we're doing with the WSL dollar. And there could be others, like the NFS client for Windows is a redirector. WebDAV has a redirector, so it's used for many different things.
And why did we choose to use the name //WSL $?
Yeah, so MUP basically goes through a list in priority order.
Mm-hmm.
And this is actually the standard priority order that they happen to be in if you have a new install. And for example, with the TS client example I just gave you, if you are connected to a remote desktop and you have you're sharing your host drives, and you happen to have a machine on your network that is called TS client,
right?
That machine is now unreachable because MUP will give this path to RDPDR first.
Oh.
And that says, okay, I know how to handle this, and then MUP stops. And the same thing happens with us. We get the request we basically get any request for any network path. But we just look, is the server name of this WSL dollar? If not, then we pass it along. If not, if it is, then we handle it. And the reason we picked WSL dollar is because we didn't want to break you if you had a computer on your network that's called WSL.
Ah, okay.
Because dollar is not a valid character for a machine name.
Right, of course.
So, if you're wondering, like, we could have put P9 RDR behind SMB in terms of priority, then you kind of have the opposite problem. When you have a machine called WSL, now you can't reach WSL files anymore.
Right.
And that also would mean that we always would have to wait for SMB to time out before we get the request.
Okay.
Which is not desirable. So, the Plan9 redirector, it's basically it's a normal redirector in terms of Windows, so it acts like a network file system. It implements a client for the Plan9 protocol, but it has some extra knowledge in how to talk to WSL. Basically, whenever a WSL instance is started, the Plan9 server creates a Unix socket somewhere on your C drive. And we've had for a few releases, I think, the ability to interop between Windows and Linux via Unix sockets. It's something we added Unix sockets to Windows, and we exposed the ability to use that to communicate between Windows processes and WSL processes. So that is what we're doing here. So when the Plan9 server starts, it creates that Unix socket, it listens on it, and LXSS Manager will talk to the redirector, telling it, hey, there is a distribution called Ubuntu, and this is its Unix socket path. So when we actually receive a request for a network path, we first see, like, okay, is the server name WSL dollar? If so, we can handle this. Then next we see what would normally be the share name. For us, it's the distribution name.
Right.
And then, so we look at that and go like, okay, is this in our list of known currently running distributions? And if it is, then we establish a connection to that Unix socket, and then we start exchanging 9p2000 messages with the server, just like any network protocol from that point on.
Got it. And then that connection is done through LXS Manager.
Well, the connection itself doesn't go through LXSS Manager. It's just there's just a Unix
socket.
somewhere.
That's where the communication is going through.
Communication goes straight like that. LXSS Manager's only job here is to tell the Plan9 redirector where to connect to, and when the instance shuts down, we will also tell it, like, hey, you can't connect to this anymore.
Right. Okay. Awesome. And so what happens if the distro isn't currently running when we try to access this file?
Yeah, so that's something we had to consider. Originally, we were kind of thinking that's something we might do for the next release, not initially, because if you have a file open, like if LXSS Manager wants to shut down a distribution because there's no open bash windows, and I think there's a 15-second timeout once the last client goes away, and then it wants to shut that down. Now we check if the Plan9 server has any open files. And if it does, then we won't shut down the instance. So that makes sure that if something's open, we don't just invalidate your handle and stuff breaks. The problem is, in a lot of text editors, like Visual Studio Code or Notepad++ or whatever, I think Notepad actually does keep files open, but most text editors don't keep the file open. They open it, read the contents, and close it. And they're done. And then if you modify the file and you hit save, at that point it will reopen the file and write the new contents, whatever. So we thought it would be pretty bad if halfway in that process your instance shuts down and you hit save and you get an error message.
Yes, that would be bad.
So And I mean, we could tell people like, hey, no, don't close your bash windows while you're using this, but that's not really a nice user experience.
Of course.
And there's even situations where like Windows Update decides to restart your machine and reopens Visual Studio after the update, and it has your file open. It's trying to reload it, and now the instance isn't running. Things like that.
Right.
So in order to support that, what we did is we had to add an extra service for this because of some context that isn't present. Normally, because this service is running as local system, and normally WSL.exe makes a COM call to the service, and then the service can impersonate you and start an distribution on your behalf.
Right.
When we get a create, the actual the token, the security token that is to be used for that create, is stored inside the create information, which may or may not be the actual token that the thread is running under that we get the create from. Okay. Especially if a filter got involved and like spun up a worker thread to do something with this file. And if we give that token information to LXSS Manager, it wouldn't be able to impersonate you. So it can't start a distribution on your behalf. So we have to have something that's actually already running as you, as your user account, which is a new service, which is called originally LXSS Manager User. I should have had a bigger box there.
Okay.
It's LXSS Manager User. That is a per user service. If you look in your list of running services, you will see it's called LXSS Manager User _ some weird number. That's because every logged on user gets an instance of this service that runs under their own user account. And we actually, as a longer term goal, want to move more of the functionality from LXSS Manager to this service because a lot of the code in LXSS Manager doesn't strictly need to run as local system, so if we can reduce the privileges it has, that would be great.
Right.
So what happens if we get a create for Ubuntu and the redirector doesn't have Ubuntu on its list of known distributions and how to connect to them? So when LXSS Manager User starts, it actually sends an ioctl to, this is getting a bit messy, but whatever. It sends an ioctl to the redirector, which we keep in a pending state. And as soon as the create comes in for a distribution name that we don't know, we complete that ioctl with the name of that distribution in the output buffer. Okay. And LXSS Manager User talks to the regular LXSS Manager to see if there's a distribution with that name and if it can start it. Okay. And since that's a normal COM call, the LXSS Manager can impersonate you and start the distribution and everything. Right. We wait for that distribution to come up, at which point LXSS Manager informs the redirector where to connect to this. Then once that's done, the user service pens a new ioctl, both to tell it, hey, I'm done, and this can be used the next time you need to do this.
Okay. So all the mechanism for starting it up.
Yeah.
Hosted in there.
Yeah.
Right.
And once the redirector receives that reply, it basically retries all the creates that were waiting on it to see if, like, hey, do I now know where this distribution, how to connect to it?
Very cool. And so that summarizes the story of how we can access through Windows Linux files.
Exactly.
Awesome. I think that's all the questions we've had. So if you have any more, please feel free to reach us out on Twitter. You can reach me. I'm at Craig A. Loewen. Sven, you're also on Twitter.
Yes, it's Sven Groot _MS. I'm not very active on Twitter, so but I'll if I see somebody ask a question, I'll try to reply if I can.
Perfect. And if you have any more, you can always comment on the bottom of this video. We'll look at those as well. Thank you very much. We'll see you next time.
Thank you.